First, they submerge the blades in a bath of molten salt. The heat is intense, 760 degrees Celsius. The blades soak for about a minute, the time it takes for the metal temperature to rise to that of the tank. As it does, the steel's molecular structure begins to change. From here, they transfer the blades to 2 successively cooler salt baths. That quenching, as it's called, further hardens the steel. The blades are then tempered in an oven for 8 hours at 204 degrees Celsius. This gives the steel memory, meaning the blade will revert to its original shape when bent. After heat treatment, lukewarm water jets rinse off the salt residue and cool the metal to room temperature. Now that the metal has the required properties, the blades need the right profile. A worker lays them on a magnetic plate that angles them downward. The plate spins, running the blades against a grinding wheel. It takes about 30 seconds of grinding to profile each blade and form the flex point, the thinnest and most flexible part that's 3.8 centimeters from the end of the blade. Blade profiles vary because some jobs require a more flexible tool than others. Now they clean the blades in a revolving drum filled with absorbent sand. This removes oil and other residues left by the production process, and it preps the surface for the protective layer of lacquer that's applied next. After coating the blades in lacquer, they dry them in an oven. This seals the metal, preventing rust. Assembly is completely automated. The first machine slips on the plastic handle. The next machine rivets it on. The following machine slaps on a label that identifies the size and type of putty knife. Professional quality putty knives have a thicker, stiffer blade. The handle is made up of 2 halves. The machine positions them onto the handle portion of the blade, then attaches them with a hollow rivet. This enables the knife to be hung up. This factory also produces retractable utility knives. It puts the cast aluminum handles through a machine that uses polishing stones to remove any shards of metal. Workers assemble the utility knives manually, first installing the push button that moves the blade in and out. After putting in a spare blade, they close up the handle with 1 screw. This factory produces 150 different paint preparation tools for a wide range of uses, from scraping to filling to smoothing out tape on wall joints. Garage doors come in many styles, colors, and materials these days. They can be made of steel, aluminum, wood, or vinyl. Whether you choose a style that's plain or paneled, smooth or textured, a sign of quality is that the garage door is lightweight, well insulated, and airtight. The typical residential garage door is made up of 4 panels. Each one begins as a sheet of either aluminum or steel, 2 metals that can tolerate harsh climates. The side that will show has a baked-on coat of polyester paint. Depending on the model, the sheet passes through rollers that imprint a texture, such as a simulated wood grain. Then it goes through a press that imprints a design. This model will have raised rectangles. Others have horizontal stripes or no design at all. After an automated machine cuts the continuous sheet to garage door widths, another machine folds over the edges. This creates 1.5 centimeter joints for attaching the panels. The polyester paint is elastic, so it simply stretches with the bending. Now on the back side of the sheets, they hot glue metal plates to reinforce the various components they'll later screw into the garage door. Parts such as the lift handles, the hinges, and the bracket for the electric opener mechanism. They also drill a hole through which they'll later inject insulation. Now they slide two sheets together to form a panel. They close off the ends with blocks of pine. This will prevent cold air from penetrating inside. They apply various stickers with installation, maintenance, and safety information. Then orange stick-on dots to mark the location of the metal plates into which the installer will screw the hinges and lift handles. Now they attach an aluminum bar to the long ends of each panel. This holds the panel steady during the injection process. After injection, the bars come off. They load the panels onto a carousel and begin the process of filling the hollow interior cavity with insulation. Through the hole they drilled earlier, they inject polyurethane foam, an expanding plastic insulation material that's specially designed to penetrate hard-to-access spaces. As we see in this demonstration, the polyurethane expands and becomes rigid. This creates a solid core inside the garage door. Polyurethane is one of the lightest types of insulation, so it doesn't make the garage door heavy. Here's what the inside of a panel looks like once the foam hardens. Now, workers install various components, such as the rubber weather seal on the bottom panel. This seal prevents cold and water from entering the garage under the door. Some garage door models have windows to allow in natural light. Workers first use a high-speed router to remove the rectangles where these windows will be installed. Then they insert one of several window styles available. These are double-sealed windows, two thermal panes with an aluminum spacer in between. The framing around the glass is available in different colors. It's made of PVC, a synthetic resin that doesn't discolor. The frame prevents water and cold air from penetrating. Workers pack the installation hardware. Then they weigh the box to ensure no part was left out. At installation time, they attach the door panels at the joints with hinges. A system of springs ensures the garage door is perfectly balanced and moves smoothly. If properly installed, you should be able to lift or lower the garage door using just 2 fingers. Electric motors are made up of 2 main components, one stationary, called the stator, the other a rotor that moves inside the stator. The stator has multiple wire coils. Running electricity through them creates a concentrated magnetic field that turns the rotor, creating mechanical power. The stator is lined with slots, each of which holds a copper coil. The more powerful the motor, the bigger the stator and the larger the slots. The first step is to line the slots with insulation. This insulation will keep the voltage confined to the coils. The coils are made from several copper wires wound together by programmable machines. The bigger the motor, the more wires per coil. In this motor, each coil consists of 13 strands of copper wire. Now workers tie the coils. This prevents the wires from unraveling while being inserted into the stator slots. Workers cap each coil with fiberglass insulation. Then they insulate the portion of the coil left outside the slots with fiberglass sheets. Then they insert fiberglass wedges to lock the coils inside the slots. Once all the coils are inserted and insulated, workers begin preparing the connection. They slip an acrylic insulation sleeve over both ends of each coil. 13 coils, 26 ends. Then they group these insulated wires into large power cables. The number of wires per cable varies according to the speed and voltage of the motor. They solder the grouped wires together, then insulate the cables. They tuck some inside the stator and leave others accessible to be attached to a power source when the motor's installed. Now, using a cord made of heat and chemical-resistant polyester, they bind the coils tightly to ensure they won't move when the motor spins. This unit of bound coils is known as the stator coil. They now submerge the stator in a polyester-based varnish and vacuum it right through. This thorough penetration makes the stator coil moisture-resistant. Then they put the stator into an oven for 6 hours at 135 degrees Celsius. The varnish hardens, making the stator coil rigid. Now they have to balance the rotor. If it's off kilter, the motor will vibrate, hampering performance. They balance it the same way a mechanic balances car tires, only with 100 times greater precision. Now they slowly slide the rotor into the stator, careful not to damage the stator coil. The rotor will turn on steel bearings. They heat these bearings to expand them so they'll install easily. Then they blow on cold air to shrink them to a tight fit. It's the same process with the motor's back cover. Now they heat the fan and install it over the back cover. The fan's job is to cool the running motor so that it doesn't overheat and break down. They cover the fan with a safety guard. Then install a cover on the front of the motor as well. They run the finished motor through various tests to assess, among other things, insulation strength and performance. These industrial motors are designed for use in factories, for running machinery such as conveyor belts, pumps, fans, and compressors. What do wool and hand cream have in common? Well, a sheep's fleece has an oily protective coating which contains a substance called wool grease. When factories make yarn, they first clean the wool with detergents. The grease is processed into lanolin, a common ingredient in hand creams. Historians believe that people began raising sheep for food and clothing about 10,000 years ago, and that around 4000 BC, they started spinning the wool into yarn for weaving fabrics. The Romans brought wool production to England in about 50 AD. Woolen fabrics would become the country's chief export for centuries. In 1797, Britain shipped 13 sheep to Australia, starting what would become the largest wool industry in the world today. Wool fabric is durable, wrinkle-proof, and holds its shape well. It absorbs moisture and insulates against heat and cold. That's why wool is ideal for clothing such as sweaters and coats. Sheep shearers use power shears, removing the fleece in one piece. They discard any stained or inferior wool, then sort the rest according to the quality of the fibers. This grading is based on length, color, waviness, and fineness. The wool is cleaned with detergents before processing. The wool arrives at the factory in compressed bales. Workers untie them and feed the wool into the opening equipment, whose metal tooth rollers comb out and separate the fibers. From there, the fibers go into the blending room, where air currents mix different grades of wool to get the desired texture. If they'll be weaving a wool blend, they mix the wool fibers with other materials such as polyester fibers. A thorough blending takes about an hour. An air pipe transports the blended fibers to the next station. On the way, sprayers lubricate them with a mineral oil mixture to make processing easier. The fibers arrive at the carding machine, where they pass through a series of rollers with thin wire teeth. This untangles the fibers and lines them up parallel to each other. This process also removes any pieces of debris caught in the fibers. The carding process produces a smooth, flat sheet called a web. The equipment divides this web into thin, flat strips. These strips go through rub aprons, two rollers that twirl them into thinner, rounded strips called rovings. The rovings wind onto a spool. Rovings look like yarn, but if you pull on them, they simply tear. They haven't yet been spun, so they have no strength. So each roving goes into a device called a spinning frame. It stretches the roving and spins it tightly, producing wool yarn. The yarn winds onto a bobbin. Spinning gives the yarn strength. Now they can weave it into a wool fabric. A fully automated loom does it all. Watch in slow motion as it inserts one strand at a time, crosswise, through stationary lengthwise strands. It's computer programmed to thread in a specific under-over configuration according to the type of weave. The loom inserts 400 strands per minute. After weaving, they burn off vegetal matter such as straw fragments, then dye and dry the fabric. All wool fabrics undergo finishing to give them a particular appearance and feel. These spiked rollers created a plush finish. Woolens can also have a sheared or flat finish. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at www.howitismade.net. The How It's Made crew vehicle is courtesy of Subaru Canada.